So today's subject is basics of steam. Okay. So in basics of steam, we'll learn what exactly the steam is, how it is generated, how the temperature enthalpy is related in steam. Okay. So first of all, we'll see what is steam. Okay. So can you tell me what is steam? Simply, it is a gaseous form of water.
Yes.
Okay, when the water converts from liquid phase to gas phase,
Yes.
the gas phase is called as steam.
Yes.
Okay, so clear hai? So it's a gaseous phase of water. Simple. Okay, at what point the phase changes, or at what temperature the phase changes, is called boiling point. So the point at which this water gets converted into steam is called boiling point. Okay. Now this boiling point is not constant.
Yes.
Okay. It changes with
Pressure.
pressure. Okay. So as the pressure increases, boiling point also increases.
Yes.
Clear? Now we'll see what are the applications of steam. Why steam is so important. So why the steam is used, or what applications the steam is used? Any?
For heating purpose.
Correct. So it's for heating. The steam is used for heating. That is its primary use. Next is power generation. Okay. Then for cleaning. Then for sanitization. For refrigeration. For vacuum creation. So these are the six main applications of or uses of steam. So heating, everybody knows, to heat any process, liquid, process media, we use steam. Power generation is steam turbines, right? The electricity that we get in our houses is through steam turbines. The boiler generates steams, and then steam drives the turbine, and turbine generates electricity. Next is cleaning. So cleaning any surface. Sanitization in pharma or in food industry, to sanitize the equipments, they put it in an autoclave, and then another use was humidification, not humidification, to increase the humidity in the air. The steam is used. Okay. Sanitization, refrigeration. So there is a machine called VAM, vapor absorption machine, where steam is primary source of energy to create refrigeration, chilling. Okay, very interesting, but yeah. Then vacuum. So there are vacuum ejectors. So there is a device called ejectors, mainly used in your chemical or multiple effect evaporators, where the ejectors are used to create vacuum inside a vessel or inside a column. Okay, for that steam is used. And humidification, as I said. So these are the major applications or uses, general uses of steam, out of which heating and power generation are the most commonly used. Okay. So, and as a company, we are mainly interested in heating. Okay. In heating, I'll just keep you informed that there are two processes. One is direct heating and another is indirect heating. Okay. In direct heating, the steam gets into contact with the other media. That is why it is called as direct. In indirect, it doesn't get in contact with other media. There is always something in between.
Yes.
Like there is a heat exchanger plate, and on this side it's a cold media, and on other side it's a hot media, and this is the plate or something which transfers the heat from steam to steam to other media through that surface. So the steam doesn't get in contact with other media.
Okay.
Clear? So that is why it is indirect. Now, other than applications, we have to understand why this industry is so important. Because if you start with your day in the morning, you go and brush your teeth, okay, you wear clothes, then you have the soaps to bath, then you eat salt, then take medicines or anything. So any industry or every industry requires steam as a one of this application, as one of the uses. So that is why this steam is used to manufacture each and every product that we use. Our clothes, our tires of our vehicle, salt, your chocolates, dairy products,
Even glass.
okay, anything. So anything and everything requires steam as a media for some or the other application out of this. Okay, we cannot live without this because the power is being generated on steam, using steam, right? So all these applications and uses are very important, and it touches our life every day
Yes.
or every part of our life. Understood? So now we'll continue how the steam is generated and how the enthalpy and temperature plays a role. Okay, so we'll understand it with a simple graph. Okay, this graph is temperature versus enthalpy or the heat. Okay, let's say that our initial water temperature is 30 degrees Celsius. So let's say this is a 30 degrees Celsius room temperature, and let's say the first, as we know, in the atmosphere the boiling point of water is 100 degrees Celsius. So this is 100 degrees Celsius. Okay, and this is, let's say, the water has 30 kilocalories. Okay, as we know, for water specific heat is 1 kilocalorie per kg per degree Celsius. What does this mean is, to increase 1 kg water temperature by 1 degree Celsius, we need 1 kilocalorie. Okay, so again, if you have a 1 kg of water and you want to increase the temperature by 1 degree, that means let's say 15 degrees Celsius to 16 degrees Celsius,
Okay.
then you need to give input of 1 kilocalorie of heat. Okay, so this is 1 kilocalorie. This is a specific heat. This specific heat, understanding of specific heat is clear to you?
Yes.
This is applicable to any substance. Only the value will be different. So for water it's 1, so it's a reference. So always know that the water and air generally are the references. So water is a reference. So for any chemical it might be 0.8, 0.9. Understood? So it's a different. So specific heat of any substance, every substance is different. For water is easy 1. Okay. Now, as I said, our starting point is 30 degree. So it already has a 30 kilocalories of heat. Now we started heating. We put a pan with water on gas burner and we started. So the temperature will start increasing, right? And it will reach at a point 100 degrees Celsius. Okay, at this point it's at 100 degrees Celsius. Okay, and this is the amount of heat it has gained. Okay, if during this rise or when it is absorbing the heat, we can see that the temperature is rising.
Yes.
Okay, that is why this area or the amount of heat it has absorbed is called sensible heat, because you can sense it.
Yes.
If you put your finger in the water, you can feel it that the temperature is going up. That is why it is sensible heat. Now it is at boiling point. it is at atmospheric pressure. Now still I am giving more heat, but in this case it will,
Constant.
the temperature will not change and it will keep on going like this.
Yes.
So it is at 100 degrees Celsius, but the enthalpy is going up because it is absorbing energy. During this, the phase change starts. Okay.
Yes.
At this very point, the phase change start. Okay. But the temperature remains constant. Understood?
Yes.
At this point, the complete 1 kg of water has converted to steam. Again, 1 kg is a reference, understand? It's a unit mass. Now this part is called latent heat. Okay, the heat absorbed during the phase change is called latent heat. Though this is latent heat. For water at atmospheric pressure, it requires 539.9. We round it off to 540 for easy understanding. Kilocalories per kg. Again per kg because it's for 1 unit mass, 1 kg. So 1 kg water will have to absorb 540 kilocalories of latent heat to convert into steam.
Yes.
But it is already as 100 degrees Celsius. Understood? So this is 100 kilocalories sensible heat and this is 539. So the steam at this point will have 100 plus 540, that is equal to 640 kilocalories total per kg. Understood?
Yes.
100, why 100 kilocalories? Because every degree will absorb 1 kilocalories. So it will 100 plus latent heat. So both you cannot kill the energy, right?
Obviously.
The energy can neither be created nor be destroyed, right? So total energy will be there in steam. So it will be 640 kilocalories in 1 kg. Clear?
Yes.
Okay. So 640 kilocalorie is called total heat. Now at this point, at this very point, the steam is called dry saturated. What is it called? Dry saturated, because it is completely free from moisture, but it is exactly at 100 degrees Celsius. So that is why it is saturated. Now again, if I start heating this in keeping the pressure constant, this will start going up, and this section is called superheated. Okay.
Yes.
Now this is a liquid phase. This is liquid
Moisture.
plus gas mixed. This is purely gas. Clear? Now understand, we have gone from liquid to gas. Now when it is coming back from gas to liquid, it will follow the same curve, same path. Understood? So when I give dry saturated steam to any process, it will lose first latent heat. When it is donating, now it was absorbing.
It will gain latent heat.
Understood?
Yes, yes.
So when the steam is donating donating energy, it will convert from gas to liquid by donating latent heat.
Yes.
The liquid is called condensate now.
Yeah.
It's a water only, but as it is formed from steam,
Gas.
it is called
Condensate.
condensate,
Yeah.
which will be at 100 degrees Celsius. Now, as we said that the pressure changes as we have said that the temperature changes with the pressure, right? So how does this work? Again, I'll draw the same. Okay, let's say this is 100 degree, this is 120 degree, this is temperature, this is enthalpy. Okay, so we started from, let's say, 30 degree, 100 degree, then this is 540 kilocalories,
Yes.
right? Next time at 1 bar, so this was at atmospheric pressure. Now at 1 bar it will be like this, but the latent heat will be a little less, or we should, this is not correct. It will be just slightly like this. So understand, boiling point up, latent heat down, total heat up. Okay, so the next point will be like this, next point will be like this. So the curve that we are talking about is joining this. Have you seen this curve?
Yes.
Molar chart. Okay, and this point is called critical point. Will not go into that. So understand, as we go up, you have to see that the temperature or boiling point is going to
Right.
go up.
Yes.
I should say with increase in pressure. So as we increase, so this is atmospheric, this is 1 bar, this is 2 bar, this is 3 bar, and so on and so forth.
Yes.
But the latent heat goes down. So this part goes narrowing down. But the curve is tilted toward right, so the total heat is more. So the total heat is going to increase.
Got it.
Clear?
Yes.
So this is temperature enthalpy graph. So now you have understood how the steam is generated,
Yeah.
how the enthalpy works. Clear? With pressure and temperature. Okay, so I think that's it for today.